Throughout the semester, we'll talk about a number of different applications for our price demand, revenue, cost, and profit functions. But the first one we want to talk about here is break-even analysis. What we have in the graph represented here are three different curves. We'll start off by focusing on just two of those. The graph in red is a cost function. The graph in blue is a revenue function. And what we want to talk about are just some intuitive ideas, translate those into the graph, and see how we can apply some break-even analysis with these functions. So looking at just the curve in blue and that straight line in red, we can see a couple of things happening. In the first portion of this graph, we see that our costs are achieving higher function values than our revenue functions. So that would be a section of the graph where we're actually losing money. We're spending more money than we're bringing in. And a similar scenario happens at the upper end of the curve. At some point, eventually, our cost functions become, our total cost becomes larger than our revenue again. So we have another section of the graph where our company would actually be losing money. So where we want to operate would be in between those 2 points. Anywhere where our revenue function is exceeding our cost functions would mean that our business is actually making money. And what we have then are 2 points where those two curves cross over with each other, which would be considered our break-even points. So at the point where our revenue and cost are exactly equal, we're making no money, but we're also not losing any money. And then on either side of that, we're either losing money or bringing in more revenue than our costs, so we're generating money. That same idea is also reflected in our profit function, P of X. What we would see is that at the initial portion of this profit function, our function values are actually negative, indicating that we're bringing in a negative profit, so we're losing money. We hit a section where our profits pass above zero, so we're generating some amount of profit over this region of the graph. And then again, at some production level, our profits dip back below zero because our costs are becoming too large, and we start losing money again. So what we see here are 2 points where our profit function intersects with the x-axis, and that makes the difference. At those points, our profit is exactly zero, so we're not making money or losing money. And then what we see between these two graphs is that these points that we have are exactly in line with each other, the points on the high end and the points on the low end. So when our revenue and cost are equal to each other, we're breaking even, or when our profit is equal to zero, we're breaking even. So when we talk about this break-even analysis, there will be two different ways to go about solving these types of problems. We can either set our profit function equal to zero and solve, or we can take our revenue function, set that equal to our cost function, and solve that equation. Again, in either case, what we're doing is finding the point where our functions change so that our revenue is exceeding our costs, so that our profit is greater than zero, or more specifically, we're finding that point where we change from losing money to gaining money. So that point where our profit is exactly equal, or our revenue and costs are equal to one another. Let's take a look at a couple of examples where we apply this idea of break-even analysis to find those break-even points. So in our first example, we're given a profit function where X is the number of units produced and sold, and we want to find those break-even points. So as we stated, we have two different methods for solving these types of problems. We can take our profit function and set it equal to zero, which is going to be our best route in this case since we're given a profit function. So using Wolfram Alpha, what we can do is type in the command solve and then enter our given function. Where I'm using this caret symbol, so Shift 6 on my keyboard to represent those exponents. And what we're doing is saying solve this function, set equal to zero. So we'll press enter or click that equal sign, and Wolfram Alpha will generate a solution for us, or in this case, multiple solutions. It's always a good idea, again, to check this input interpretation just to make sure that matches the problem you think you were out trying to solve. And then we can look at our results. In this case, we come up with three: -20, 50, and 400. So our solutions to taking our profit function set equal to 0 are -20, 50, and 400. And we want to pause for a minute just to think about whether or not all of those solutions make sense. So again, X is the number of units being produced and sold. A value of 400 units would make sense, 50 units would make sense, but this value of -20 doesn't really make sense. We can't produce a negative number of units. So in this case, what we want to do is throw out that particular solution, which doesn't make any sense. And we could look at this graphically. Wolfram Alpha will output that graph for us, which I've also included here. And we can see what's happening is this value of -20 is a legitimate value. It's a point where the function would intersect the x-axis. But since we're in negative x values, that doesn't intuitively make sense with our problem. We would only want to consider solutions that are at a value of x equals 0 or something larger. Anything less than 0 we would just throw out. So in this case, we could say that our given problem or our given situation, our company would have break-even points at production levels of 50 and 400. Meaning if they're somewhere in between those two production levels, then they would be generating a profit. In our last example, we want to find the break-even points for the situation described in example 8. If we were to refer back, we could see that we were given a cost function. And we were given a revenue function. Which we use to then generate a profit function. So we could generate that profit function and we could solve P of X is equal to 0. Or since what we're starting off with our revenue and cost, we could just set our revenue function equal to our cost function and solve that equation. So we'll look at an example of taking that approach. So what we'll do is still keep that solve command, but in this case, we'll set that cost equation equal to our revenue function, and then either click enter or that equals button to go ahead and solve. And we come up with two results, 260 and 1480. Both of these production levels are positive, so they make sense. They're reasonable values. And what we can see is those are our break-even points, where our revenue starts to, if we increase above this first point, our revenue starts exceeding our costs. And if we exceed past the second point, our revenue starts dipping below our cost. So at those 2 points, our revenue and cost functions are equal to each other. So we're at that break-even point where we're not generating money or losing money. So in this case, we would break even at production levels of x equals 260 and 1480.